Hi, this video is for Wednesday, April 22nd for trigonometry. Today I'm going to be teaching you about vectors and their dot product. So we've been talking about vectors the past 2 days. Today I'm going to teach you about dot product. So here's how it works. If you're given two vectors, so vector A and its components are A1 and A2, and vector B and its components are B1 and B2. The dot product is represented like this. Okay, so these are both bold letters, A and B. And their dot product is going to equal A1 times B1 plus A2 times B2. Okay, so you're going to multiply the components, the first components of each vector. So A1 times B1 plus, and then you're going to multiply the second components of the vector, A2 times B2. So you're going to multiply this, and then you're going to add them. Okay, so that is, I'm reading this straight from your notes, another way of saying what I just said. The dot product of two vectors is the sum of the product of their first components and the product of their second components, which I demonstrated it right there. Alright, so I'm going to show you an example of how dot product works. Alright, so example 1. It says, find the dot product of the two vectors. A is 2, 3, and B is negative 1, 4. Alright, so we're going to start by multiplying the first components. So we're going to take 2 times negative 1. So 2 times negative 1 plus, then we're going to take the second components, 3 times 4. So remember, we're doing this, multiplying that, and we're multiplying this, and then you add them together. Alright, so this part's negative 2, and this part's 12, and negative 2 plus 12 is 10. So the dot product of those two vectors is 10. Okay, so hopefully that's pretty straightforward so far. You take the first components from each vector, multiply them. Take the second components from each vector, multiply them. Then you add those two results together, and bam, dot product. Alright, so we're going to try example 2 now. We're going to have 3 vectors. But don't worry, that's pretty straightforward too. Okay, so example 2, we have the vectors U, V, and W. So we're trying to find the dot product of this. And U is 3, negative 1. V is negative 2, negative 2. And W, which I'm going to write down here, W is 2, 4. Alright, so we have to get the dot product of all 3 of those things. So we're going to take the first components, 3, negative 2, and 2. And we're going to multiply them. So 3 times negative 2 times 2. And then we're going to add, and we're going to multiply the second components of each vector. So negative 1 times negative 2 times 4. Okay, so let's multiply these 3. 3 times negative 2 is negative 6, times 2 is negative 12. Alright, over here, negative 1 times negative 2 is 2, and 2 times 4 is 8. So what is negative 12 plus 8? Negative 4. And that's it. That's the answer. So that's not too bad either if you can keep all the components straight and put them in the right places. Now I'm going to talk to you about some properties of the dot product. Okay, so for all vectors u, v, and w and real numbers k, the following properties hold true. Okay, so we have first property, u with dot product of u and v in that order is the same if you did it in the opposite order. And that should be true because you're multiplying the first components from each vector, and then you're adding the product of the second components. And it wouldn't matter if you put v first or u first, it would be the same thing. Okay, so let's talk about the second one. Alright, this we have the dot product of u with the sum of vectors v and w, and that is going to equal u dot product of v plus u dot product w. Okay, so that's kind of the distributive property there. Alright, now next we have, if you multiply vector u by some scalar k, and then you take the dot product with v, that would be the same as if you took the dot product of u and v, and then you multiplied it with that scalar. Alright, and then lastly, we have 0 dot product with u is going to be 0. Because if you take 0, the vector 0 would be 0 comma 0. And if you took that times the first component and the second component, they would both be 0, and then when you add that, it's going to equal 0. Okay, so those are some properties. We've got one more example to do, and then you'll have a Google form for the day. So your Google form, I think, has 5 questions. The first 4 are like example 1 and 2. The very last question is similar to example 3. Alright, so let's try it. Alright, so we have example 3. Let u, the vector u equal -2, 1, and vector v is 3, 4, and vector w is -5, 12. Okay, so the problem is 3 times vector u and then the dot product with v. Okay, so 3 times u. You do what's in the parentheses first. Okay, so 3 times vector u is going to be -6, 3. Okay, then we're going to take the dot product with vector v, which is 3, 4. Alright, so here comes the dot product. We're going to multiply the first components. -6 times 3, which is -18, plus 3 times 4. And 3 times 4 is 12. And if you add those, -18 plus 12 is -6. So that's it. So always do what's in the parentheses first, and then do what comes after that. Okay, so I hope that made sense. If not, shoot me an email, and I will gladly help you through what your problem is. Okay, so that's it. Good luck on your Google form. Tomorrow we're going to have a Google form on the things we learned this week. So tomorrow there will not be a video, but Thursday will be a review of what we did Monday, Tuesday, and Wednesday. And then Friday we're not going to have anything posted. So that's it. I miss you all, and I hope you're well. Bye.